Hi, it's Miss House. I'm going to take you through a version of the practice quiz before you take your factoring, proctored factoring quiz. So the first thing you need to remember is that you're going to take out a greatest common factor first every time. So we're going to put this at the top to remind us to look through all terms to see if there's a common factor. After we do that, we're going to count our terms. Okay, and based on the number of terms, you're going to decide what kind of factoring to do. If it's a 4-term polynomial, we're going to do a process called grouping. Okay. If it's a 3-term polynomial, we're going to use a method called the AC method. And if it is a 2-term polynomial, we're going to go with a binomial pattern. Now you want to have your calculator handy because you're going to be looking for factors, that is, numbers that will divide evenly or will multiply together to get a certain number. Now, the other thing we want to do is we want to make sure that we distinguish between an expression which will just factor and an equation which we will factor and solve. We'll actually look for the answers to the equation, but only if it's an equation. Okay, so for example, number 1, x to the 3rd plus 4x to the 2nd plus 3x plus 12. Okay, I look at my terms to see, first of all, if I have a greatest common factor. Notice that these terms have no number in common that will divide into them, and they don't have an x in common because this 12 on the end has no x. So there is no common factor. So I'm going to write myself a note, no GCF, because we're going to do that every single time, and if you forget it, it's going to mess you up. So always look for greatest common factor. Then I'm going to count my terms, and I see that I have 4 terms. And because of that, I'm going to use the process called grouping. We always do that in this class when we have a 4-term polynomial. So I'm not going to put parentheses or anything. I'm just going to say I'm going to group the first 2 together. I'm going to drop my middle sign, and I'm going to group the last 2 together. And so I'll briefly ignore these last 2 and look only at the first 2, and I notice that they have an x squared in common. And if I take out the x squared, I'm going to need an x excuse me, plus 4. Now make sure this multiplies for x cubed and this multiplies for 4x squared. You're reversing the distributive property here. You're pulling out the common factor. Here I notice they have a 3 in common. That would leave an x plus 4. And this is the situation that we're hoping we find, and that is that these have a common factor of x plus 4. Happens to be a binomial, but it's still a common factor. And then if I factor out the x plus 4, this one has an x squared, and this one has a plus 3 left. Now, if I check this by foiling, you know, when you multiply a binomial times a binomial, we have a little mnemonic device called the FOIL rule, where we multiply first, outside, inside, last. The first two, the outer two, the inner two, and the last two. First, outer, inner, and last. You can multiply those to check to make sure that you have factored correctly. Now, you may get different order. For example, I would get x cubed plus 3x plus 4x squared plus 12. And you'll notice this is in a slightly different order, but I can put this in standard form by making sure that the exponents descend or go down in order, and you will see that it checks. So if you have time, always take the opportunity to check. If it's a binomial times a binomial, you FOIL it out to see if you get the original problem. So that's number 1. This is our final answer for number 1. Number 2, 15a squared plus 6a minus 25a minus 10. So the first thing I'm going to look for is to see if they all have a common factor. They don't all have an a. And let's see, 15 is divisible by 3, 5, and 15. Of course, 1 will go into all of them, but we're looking for something other than 1. 6 has a 2 and 3 in common. 25 has just 25, 5, and 10 is 2 and 5. And the problem is the 6 doesn't have a 5 in there, and 25 doesn't have a 2, and only 15 and 6 have a 3. So there's no GCF. So I'm going to write myself a note because I need to look for greatest common factor every single time. Then I count my terms. I have 4 terms, so I need to use this process known as grouping. So we group the first 2 and the last 2, and the middle sign, we go ahead and bring that down. So looking at the first 2 only, we see that 15 and 6 have a 3 in common, and they both have a factor of a. Then reversing the distributive property, this would be 5a plus 2. And look, that's 15a squared plus 6a. Minus sign has dropped down. 25 and 10 have a 5 in common. They don't both have an a, just a 5. And so I'm going to need a 5a, and I need to be careful here. A minus and a positive will make a negative. So negative 5 times positive 2 is negative 10. Again, we see we have a matching binomial, common factor, 5a plus 2. And then if that's factored from each of these, that leaves me with 3a minus 5 for my second factor. And then I should FOIL that out, especially on a test, just to make sure that it works. And it will. Okay, I'm not going to take the time to do it here, but you should, especially on your proctored assignments. Number 3. I have 2b to the 5th minus 8b to the 4th plus 4b to the 3rd minus 16b to the 2nd. I always start with greatest common factor. And I notice this time that 2 will divide into all of these. And look, they all have at least b squared. So I'm going to take out 2b squared. Then I need to divide. I'm reversing the distributive property. This will be b to the 3rd, because 2 and 3 will make 5, and 2 times 1 is 2. And then 2 into negative 8 is a minus 4. I need a total of b to the 4th. 2 plus 2 makes 4. plus 2 goes into 4 2 times. I've got b squared, but I need b to the third, so I need a b. And then 2 into 16 is going to be minus 8. And then there's b squared already here, so I don't need any more b's here. So this is my greatest common factor. And I go ahead and put it down here in my final answer so that I don't forget it. And then I can proceed to doing this 4-term polynomial by grouping. So I'll do the first 2, drop this sign down, and the last 2. I notice that these 2 both have b squared. If I take out a b squared, I have a b minus 4 left. B squared times b is b cubed. B squared times negative 4 is negative 4b squared. My plus sign is here. I'm going to take out a 2, and left inside will be b minus 4. So this is what I was hoping for. They have a common factor of b minus 4. Those have been factored to the front. So this one has come to the front, this one has come to the front. It leaves b squared plus 2 for my second factor. And I've already got my greatest common factor down here, so I go ahead and I write my final answer down there with the greatest common factor. Now, if I want to check this, I need to FOIL out these 2 binomials first and then multiply everything by 2b squared to make sure that I have the correct answer. Okay, so that is factoring by grouping. We always look for greatest common factor, and if it has 4 terms, we group first 2, last 2. Don't forget to bring your middle sign down. All right, so the next kind of factoring we have, you'll see, is a trinomial. So number 4, w squared minus 7w plus 6. And if a trinomial will factor, it will be a binomial times a binomial. So once again, we are reversing the FOIL rule. So this is reversing FOIL. So we've multiplied it out, and now we need to go backwards. So remember, there are 4 terms when you do the FOIL. But in a trinomial, there are only 3 terms. So we're going to, number 1, look for a greatest common factor, which in this case there isn't one. And then we're going to look at the first number, which happens to be a 1 here, times the last number, and this is called the AC method. And we do this for trinomials. Our trinomial will be of the form ax squared plus bx plus c, and a times c is why we call this the AC method. So for us, 1 times 6 is 6, and then we look at our b, and our b is negative 7. So we're looking for the factors. Okay, I always make a little chart here. AC is 6, and b is negative 7. We're looking for the factors of positive 6 that will add to negative 7. Well, 1 times 6 is 6, but they add to positive 7. So we need a negative 1 and a negative 6, and that will add to negative 7, right? Negative plus a negative is going to be a negative. Now what we do next is we split our middle term, right? We split our 7w into the O and the I of the FOIL rule. So it's going to be minus 1w minus 6w plus 6. So this 7 gets split into the factors of AC that will add to B, we found those to be -1 and -6. And now guess what? After we've done this, we're back to grouping. So we group the first two, bring down the middle sign, group the last two. So you'll see these two have a W in common. Let's see, let me erase that. Kind of came up. So they have a W in common, and that'll give me a W minus 1. I drop the minus sign down. These two have a 6 in common. That will also leave a W minus 1. Now, if you get these right, these will automatically have a match. Okay? So W minus 1 and W minus 6. Okay? If you can find the correct AC that adds up to B, the factors of this first number that add up to this number, you will always have a match. It will never be prime. Okay? Now, you might say, well, why can't I just go to the directly to the answer? You can. If this is a 1, it's always going to factor whatever this variable is, whatever this number is, whatever this number is. So W minus 1, W minus 6. However, if this is not a 1, you have to definitely do the split and do the grouping method. So I'll do all of them with the grouping method, even though you can do a little bit of a shortcut on these. And if there's a 1, just put the factors in the parentheses. Number 5. W squared plus 10W minus 24. So I look for GCF, and there's no GCF. I count my terms. There are 3 terms. So since there are 3 terms, I use the AC method, and for us, AC is -24, and my B is +10. So I'm looking for factors of -24 that will add to +10. Now you may notice them immediately, but if you don't, just start -1 times 24, -2 times 12, and there it is. Look, -2 plus 12 gives me 10. So W squared minus 2W plus 12W minus 24. Again, this is splitting it back like when we did the O and the I of the FOIL rule, the outer and the inner. Group these two, drop this sign, group these two. These two have a W in common. That will give me a W minus 2. These two have a 12 in common, and that will give me a W minus 2. So the common binomial, W minus 2, what's left over? W plus 12. And again, because there's a 1 here, look, I can go directly to W minus 2, W plus 12. That's number 5. Number 6, W squared plus 6W plus 8. I look for GCF. There is no GCF. I count my terms. There are 3 terms. I multiply A times C. I get 8, and my B is 6. I need the factors of 8 that will add up to 6. So we got 1 times 8 and 2 times 4. And look, these are both positive. Everything's positive here, so +2, +4. We could do the shortcut. W plus 2 and W plus 4. So I could also split this apart as W squared plus 2w plus 4w plus 8. That's the O and the I of the FOIL rule. That's why we need to split it apart to see why these are the two factors. Well, if you do it this way, you group the first two, take out the common factor, bring down your middle sign, group the last two, take out the common factor. The common factor is w plus 2 now, and w plus 4 is my second factor. And of course, you can always FOIL to make sure you have the correct answer. That is number 6. Now we get to one where there is not a 1 in the very front of the trinomial. Number 7. 5z squared plus 9z minus 2. I look for greatest common factor. There is no common factor. There will be sometimes, there just hasn't been so far. We count our terms. We have 3 terms. That means we're going to use the AC method. Okay, we multiply A times C. We get negative 10. 5 times negative 2. B is our coefficient in the middle. That is 9. I need the factors that will give me negative 10 that could add up to 9. And look, negative 1 times 10, not times 9, times 10 is my answer. Because look, negative 1 times 10 is negative 10. Negative 1 plus 10 is 9. So my 9z gets split. 5z squared minus 1z, and it's okay to write the 1 there, plus 10z minus 2. Group the first two, drop the middle sign, group the last two. The first two have a z in common. 5z minus 1, if z is taken out. The last two have a 2 in common. 5z minus 1. So my answer is 5z minus 1 and z plus 2. And so you can see I can't go directly to the answer this time. If A is not a 1, you must do the split and do grouping. That's my final answer, 5z minus 1 times z plus 2. Number 8. 2x squared minus 38x plus 96. The first thing I do is I look for a GCF, and guess what? We do have a GCF this time. So 2 will come out. X squared minus 19x plus 48. So now my A is, look, this 2 is going to come down in my answer. And I can ignore it. I'm just going to look at this. So my AC is 48. It has to combine to negative 19. So let's see, negative 1 times negative 48. Look, they have to both be positive to multiply for a negative. I'm sorry, to multiply for a positive, they must both be negative to multiply for a positive and add to get a negative. But that doesn't add up to negative 19. That's negative 49. Negative 2, negative 24. That multiplies for positive 48, but it adds to negative 26. Negative 3, negative 16. Notice I'm just going in order. If the number goes in a decimal number of times, just don't write it down. You can use your calculator to do this. But look, this is the combo that I need. Negative 3 times negative 16 is positive 48, and they add to negative 19. Now look, this is now one of those easy ones where this is a 1 here. So I can do the split of minus 3x minus 16x and group, or I can go right to the answer, x minus 3, x minus 16. Because even though it didn't start out with a 1, there was a common factor that came down, and so my trinomial that's left does have a 1 there, and I can just go directly to the answer. That's number 8. Number 9. X cubed minus 2x squared minus 35x. I look for a common factor. This time there is a common factor. All of these terms have an x in common. So that's x squared minus 2x minus 35. So the common factor was x. That would leave me with an x squared, because I need x times x squared to give me x cubed. X times negative 2x gives me negative 2x squared, and x times negative 35 gives me negative 35x. So look, this is my common factor. I put it down here in my answer, and then I can ignore it for now and just focus on this. So my AC is negative 35. My B is negative 2. So I need to multiply for negative 35 and add to negative 2. So negative 1 times 35 will multiply for negative 35, but it certainly doesn't add to negative 2. So the next thing that will go into negative 35 is negative 5. Negative 5 times positive 7 gives me negative 35, but when I add it, it gives me a plus 2. So what I really need is a negative 7 and a plus 5. Again, this is a 1. I can go directly to the answer, x minus 7, x plus 5. And don't forget, your greatest common factor has to also be listed in your answer. That's number 9. Number 10. S squared plus 2s plus 10. I look for a greatest common factor. There is no common factor. They don't all have an s, and there's no number that will go into 1, 2, and 10 other than 1. So technically they do have a greatest common factor. It's 1. But it wouldn't do us any good if we take out a 1. We'd be left with the same expression. My AC is 10. My B is 2. I need the factors of 10 that add up to 2. All positives, because everything here is positive. 1 times 10 doesn't add to 2. 2 times 5 doesn't add to... Uh-oh. What does that mean? There are no factors of 10 that could possibly get us a 2. This polynomial is prime. Okay? It's a trinomial where there is no combination of AC that will combine for B, and that's how we know that it's prime, and we don't have to do anything except write that it's prime. Number 11. 14x squared plus 19x minus 3. I'll look for greatest common factor. There is no greatest common factor. This is a trinomial. That is 3 terms. That means I have to use the AC method. My AC is 14 times negative 3, negative 42. My B is 19. I'm looking for the factors of negative 42 that add to 19. Negative 1 times 42 is not correct. Negative 2 times 21 will multiply for negative 42 and add to positive 19. So I split my middle term, the 19x, into minus 2x plus 21x minus 3. Then I factor the first two together, I drop the middle sign, I factor the last two together. The greatest common factor of these two is 2x, 7x minus 1 would be inside the parentheses. The factor that's in common in these two is 3, and 7x minus 1 will be in this set of parentheses. Their common factor is 7x minus 1, and the other factor is 2x plus 3. So I can FOIL this to check it. That would be 14x, 21x minus 2x. See, that's the two numbers from the FOIL rule. And then minus 3 would give me the minus 3. Negative 1 times 3. That's number 11. If it's 4 terms, you group. If it's 3 terms, you AC, and then you group. And if it's 2 terms, you're going to look for a pattern. Okay? And of course, greatest common factor comes before any of this. So you got to look for your greatest common factor. So these are the patterns that you need to recognize. You have one number that is a square, subtract another number that is a square. This is called the difference of squares. Difference is subtract. Squares are two numbers just alike that are the factors of a number. And so the pattern for this is, since a squared has two factors that are just alike, a times a, and b squared has two factors, b times b, you take one of each with a plus sign and the other two with a minus sign. And when you FOIL this out, what happens is AB and minus AB, you get a squared minus AB plus AB minus b squared, and these two will cancel out to give you a squared minus b squared. So if we have one like number 12, 64w squared minus 9, first of all, we look for greatest common factor. Nope, no greatest common factor. We count the terms. It's 2 terms. That means it has to fit a pattern, and the first pattern is the a squared minus b squared. So look, this is 8w times 8w. And if you can't come up with two numbers that are just alike, then you don't have a perfect square and it doesn't fit this pattern. This is 3 times 3. And there's a minus in between, and that's important. If there's a plus, it's completely different. But when there's a minus, it's 8w plus 3. That's one of each with a plus, and 8w minus 3, one of each with a minus. If you FOIL that out, you'll get a 24w and a negative 24w, and those will cancel out, and you'll get 64w squared minus 9. Okay, number 13. 75a squared minus 108 b squared. So I look for a GCF. Now, here's a good time to review how you find GCF. I look at these and I think, oh, maybe they don't have anything in common, other than 1, of course. 2 won't go. Let me see if 3 will go. So I'll get my calculator out. 3 goes into 75. That's 25 times. Okay. Will 3 go into 108? Let's see. 3 times 3 is 9. Yeah, 36 times. So look, it has a common factor of 3. 25a squared minus 36b squared. So I've got to take that GCF out so that I see now that this is a difference of squares. My common factor is going to go down here to my answer so I don't forget it. This is 5a times 5a. This is 6b times 6b. So it fits the pattern for the difference of squares, one of each with a plus. Whoops, let me do that right. 5a plus 6b. And 5a minus 6b. Okay? So because it fits the difference of squares patterns, I know that if I find the two factors just alike here and the two factors just alike here, I put one with a plus sign and one with a minus sign. And of course GCFs have to always be in the front. Now to check this, you could FOIL these two. Look, 25a squared minus 30ab plus 30ab, I'm just doing the FOIL rule, minus 36b squared. Look, I forgot my b there, so I'm glad I checked. Minus 36b squared. Those zero out, and I have 25a squared minus 36b squared. Now, had I not checked it, I might not have caught my mistake. Look, it's one of each, 5a, 6b with a plus, and one of each with a minus. So checking is always a good idea. All right. Number 14. Now this one is different because it's 25 plus y squared. So this is 5 times 5, and this is y times y. So this is called the sum of squares. And here's the good thing about the sum of squares. The sum of squares with no GCF, right, is prime. Okay? And the reason for that is, look, if I do 5 plus y and 5 plus y, I get 25, that's good, plus 5y, plus 5y, plus y squared. And look, I've got a 10y here in the middle. There's no 10y up here. So that can't be it. If I alternate them, 5 plus y, 5 minus y, well, that's going to be the difference of squares. That's going to come out to 25 minus y squared. And if I put 2 minuses, that's not going to work either, because look, this is a plus. There's no way 2 minuses is going to work in there. You're going to end up with 25 minus 10y plus y squared. So that's not it. So the sum of squares without a GCF is prime. So number 14 is easy. That is prime. Okay. Number 15. Y cubed minus 343. And y cubed is not a square, it's a cube. This is called the difference of cubes, and the pattern is different than the difference of squares. Now, what we mean by cubes is that there are 3 numbers just alike that when factored will give you this number. Okay? So here are the perfect cubes. 1 cubed is 1. 2 cubed is 8. You could do these on your calculator. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. That's the one we need. 8 cubed is 512. 9 cubed is 729. 10 cubed is 1,000. And I doubt seriously you would ever see any cube bigger than that in any problems. But the one we need is this one, 7 cubed. So this is 7 times 7 times 7. Now here's the pattern for the difference of cubes. A cubed minus B cubed. Okay? A cubed minus B cubed. So first of all, you want to identify what are the factors that occur 3 times for each one. And this one's easy. It's A times A times A, B times B times B. This one's Y times Y times Y, 7 times 7 times 7. The first thing you're going to do is you're going to make a binomial, A, and whatever this sign is, minus B. Okay? And then there's actually going to be a trinomial. So I'm going to make my parentheses longer, and I'm going to put A squared, and whatever this sign is, I'm going to put the opposite, which is a plus. In the middle, one of each of these, AB. On the end, a plus, and what's left over, B squared. So this is the pattern that you need to learn for the difference of cubes. Okay? So watch how I apply it to y cubed minus 343. Y cubed minus 343, where we have y, and 7 times 7 times 7. I take one of each, y minus 7. Okay? I use the same sign that I see in the problem. Now, the reason I keep saying that is in a minute we're going to do the plus, and the sum of cubes is going to work, whereas the sum of squares did not. In the front, y times y, y squared. In the middle, opposite sign from this, and one of each multiplied, so 7 times y, and on the end, 7 times 7 is 49. So the rule for the signs here is there's a little mnemonic device called SOAP. Same as the problem, minus and a minus. Opposite from the problem, plus. Always positive on the end. Always positive. Okay? Now, let's multiply this out. Let's prove that this actually works. This is what we got. I have to multiply y all the way through. So I get y cubed plus 7y squared plus 49y. Now I've got to multiply 7 all the way through. Minus 7y squared minus 49y minus 343. 7y squared minus 7y squared. Those are opposites that add to 0. Positive 49, negative 49. Those are opposites that add to 0. Look what's left. Y cubed minus 343. Let's do another difference of cubes. 125 u to the third minus v to the third. Now we have to look for GCF, and there is no GCF. So I'm looking for a pattern. The only patterns we've seen so far, a squared minus b squared. Well, those are squares, but these are cubes, so it's not that one. A squared plus b squared. Well, it's not that one because that's a plus, and also those aren't squares. Then a cubed minus b cubed we did, and we said it's a minus b, a squared plus ab plus b squared. So let's see, 125. We said that was 5 cubed a minute ago. Now, if you need to check to see if that's a perfect cube, you can do it on your calculator. 3 second caret key. 3 second caret key, 125. Hit enter. That'll give you 5. So you know that this is 5u times 5u times 5u, and this is v times v times v. One of each, 5u minus v. What's left over? 25u squared. One of each multiplied, plus 5uv. What's left over? V squared. Same sign, minus, opposite of a minus is a plus, always positive. This is the answer for number 16. Okay, it's all pattern driven. Now in number 17, we're going to switch over to the sum of cubes pattern. A cubed plus b cubed. So the good news is it's almost exactly the same except for the sign. So look, a cubed is a times a times a, b cubed is b times b times b. I take one of each with the same sign, so this time a plus. What's left over? A times a is a squared. One of each multiplied with the opposite sign. So I got to put a minus. This is what helps things cancel out so that we just end up with these two terms. So minus ab, and then b times b, always positive, b squared. Okay, so look, in number 17 we have 54 x to the 6 plus 2 y cubed. We check for GCF, and this time there is a GCF of 2. So 27 x to the 6 plus y to the 3rd. Okay, we're going to bring this 2 down, get him out of our way. I'm going to write this as 3x squared times 3x squared times 3x squared. Look, 3 times 3 is 9 times 3 is 27. X squared times x squared times x squared is x to the 6. And this is going to be y, y, and y. So I take one of each, 3x squared, same sign, and y. So I use this 3x squared and this y, and I put them with the same sign. Now I'm going to multiply these two. That's a squared. So 3 times 3, 9, x to the 4th, because x squared times x squared. And now I need to write the opposite sign. Plus, opposite is minus. Now I'm going to multiply a 3x squared and a y. That's going to go in the middle. Okay, you just take one of these times one of these, and then the last term is always positive, and it's whatever's left over here, which is going to be y squared. And if you full that, not full, but if you distribute that out, the 3x squared and then the y, and then you multiply by 2, you'll come back up to 54x squared plus 2y. By having this opposite sign here and here, a lot of the terms will add out to 0. That's number 17. Okay. Number 18. Okay. 27 x to the 5th minus 64 x to the 2nd. Okay, well, these aren't squares, but look, I have to do the GCF first. I mean, they aren't cubes. There is a GCF this time. It's x squared. Then that leaves me with 27x cubed minus 64. Okay, This is my GCF. It's going to come down. Then I'm going to take the time to write out 3x times 3x times 3x and 4 times 4 times 4. So what we're saying is for the pattern, A is 3x and B is 4. Okay? So we take one of each with the same sign. That's 3x minus 4. And remember, the pattern says A minus B, A squared plus AB plus B squared. Well, A minus B is just one of each of these with the minus sign. A squared is what's left over here, 9x squared. One of each plus sign minus, so 3x times 4, 12x, and then what's left over here, 16 goes in the back. So the final answer is x squared times 3x minus 4 times 9x squared plus 12x plus 16. Okay, now that covers all of the rules of factoring. Make sure you start with GCF, and then you count your terms. 4 terms you group, 3 terms you AC, and 2 terms you look for one of those patterns. Then we get to equations, and the equation steps are pretty easy. Number 1, simplify both sides. So if there are any like terms or any multiplication or anything that you can do, you do that first. Number 2, set equal to 0. That is critical. It must be set equal to 0. Number 3, factor completely. Okay, look for a GCF, count your terms, do all the factoring like we just did. Number 4, set each factor equal to 0. And then number 5, solve each factor equal to 0. So you'll have some new little equations to solve, and that'll be your solution. So when we have one like number 19, simplify. Well, there's not anything I can do to this. Okay, I can't. There are no like terms. There's no parentheses. It's nice. It's in standard form. It's great. Set equal to 0. Well, that's already done. So we're starting at step 3. We're going to factor completely. Okay, so we look for a GCF, and there is no GCF. Then it's a trinomial, so we got no GCF. We count, we got 3 terms. We know we can do the AC method, and it is the shortcut one because there's a 1 here. So AC is -6 and B is 5. So I need the factors of -6, -1 times 6, that add to 5, and there they are. So it's A minus 1, A plus 6 equals 0. So look, we just did step 3, factor completely. Now we have to set each factor. A minus 1 equals 0. A plus 6 equals 0. And now we solve each factor. So I'm going to add 1 here. A is 1. I'm going to subtract 6 here. A is -6. Those are the 2 solutions to this equation. Now, it never hurts to check. When you substitute, put parentheses around the number you're substituting. This will keep you from missing signs. Okay? So 1 squared plus 5 times 1 minus 6 is 1 plus 5 minus 6. 6 minus 6 equals 0. That checks. -6 squared plus 5 -6, notice the parentheses, subtract 6, well that's negative times a negative, positive 36, minus 30 minus 6, 6 minus 6 equals 0. That one checks. Those are my two answers. Now we write a solution set and Alex sets it up for you, but you use these curly braces and you put your numbers in the solution set. And I like to put the smallest one first, but it doesn't matter. Okay, so let's recap these steps. Make sure it's completely simplified on both sides and then get everything on one side so you have a 0 on the other. Factor completely, set each factor equal to 0, and then solve each factor. Okay, so look at number 20. 4a squared minus 7a equals 15. Well, I can't combine like terms or anything, but I can move my 15 over. So 4a squared minus 7a minus 15 equals 0. I look for a GCF. There is no GCF. I do my AC, since this is a trinomial. I get negative 60, and my B is negative 7. So I'm going to start listing my factors of negative 60. I'm looking for them to add or combine for negative 7. So negative 1 times 60, that won't do it. Negative 2 times 30, that adds to 28. Negative 3 times 20, that adds to 17, not 7. Negative 4 times 15, that, oops, that's a 15 there. That adds to 11, not 7. Negative 5 times 12, that's positive 7. So if I reverse these to positive 5 and negative 12, that will give me a negative 7. So I'm going to split this apart. 4a squared, now this is not a shortcut problem because of this 4, plus 5a minus 12a minus 15 equals 0. It doesn't matter what order you put these two up here. The minus 12 can come first, or the plus and the plus 5 second. But once I've split this term into two numbers that will multiply for AC and add to B, I'm going to group, I'm going to drop this sign, and I'm going to group. So I'm going to take out an A, and I get a 4a plus 5. I'm going to take out a 3, and I get a 4a plus 5. I factor out the common binomial, 4a plus 5 and a minus 3, and then I set each factor. 4a plus 5 equals 0, a minus 3 equals 0. So let's solve these. We subtract 5 here. 4a equals negative 5, divide by 4. We got a fraction, that's okay. Equations can have fractions for answers. Over here, this one's a nice whole number. A equals 3. So my solution set is negative 5 over 4 and 3. So I had to do that AC method that time. All right, let's keep going. Number 21. 4u squared equals 11u. So there's no simplifying I can do. I need to get a 0. So 4u squared, I'm going to minus an 11u, so it's going to be minus 11u on this side. Right? If you do minus 11u here, you have to also do it here. Over here it becomes a 0. GCF, be careful, this time there is a GCF. Both of these have a u. 4u minus 11 equals 0. The first factor is u. U equals 0 is an answer. 4u minus 11 equals 0. I have to do a couple of steps. Add 11 and divide by 4. So U is also 11/4. So my solution set is 0 and 11/4. So don't forget, this GCF actually gives us an answer, U equals 0. And then the second factor, 4U minus 11, gives us the other answer. All right, again, quick recap. We're going to simplify both sides. We're going to get it equal to 0. We're going to factor it, set the factors to 0, and then solve each factor. So number 22. 9 parentheses C minus 2 minus 3 parentheses C plus 5 equals -4. I think they tried to trick us on this one. Because look, once we simplify, that's 9C minus 18 minus 3C minus 15 equals -4. Combine like terms, 6C minus 33 equals -4. Well, we don't need to factor because look, there's no square in here. So they kind of tricked us here. This is just a regular old equation. You add 33, you get 6C equals, what's that, 29? We divide by 6, C equals 29/6. So look, when the exponent is a 1, it's just a plain C, there'll only be one answer. When your exponent is a square, there will be two answers. So they put this one in here just to kind of see if we're paying attention. We don't factor unless there is a square or higher. Number 23. 6p squared minus 10p minus 4 equals 0. Always start with a GCF. This one does have a GCF. 2 can come out. 3p squared minus 5p minus 2. Okay? Now, this 2, I'm going to eventually set equal to 0, which makes no sense. So since this is a number and not a variable, I can disregard it. Okay? Both of my answers are going to come from this 3p squared minus 5p minus 2. Look, the square tells us two answers. They're still in here. You can disregard a constant like this. So multiply a times c, that's -6, and b is -5. So the factors of -6, that will give me a -5. -1 times 6 gives me a +6. 1 times -6 will give me a -5. This gives me a -6 but a +5. This gives me a -6 and a -5. So I'm going to split this apart. 3p squared plus 1p, you can put a 1 in front of it there, minus 6p minus 2 equals 0. These have a p in common. 3p plus 1 minus 2, 3p plus 1. If I can get this to be true, there'll always be a match there. 3p plus 1, p minus 2 equals 0. I am now in factored form. I set each factor. 3p plus 1 equal to 0. P minus 2 equal to 0. This is the easy one. Add 2. P equals 2. That's one of my answers. Subtract 1. 3p is -1. Divide by 3. P is -1/3. -1/3, +2. Those are my answers. I'll put them in my solution set. And of course, it's never a bad idea to check at least one of these. Maybe check the 2 in the original to make sure that it works. That was number 23. Number 24. A plus 5, a minus 3 equals 9. Now, we cannot do this until there's a 0 here, and we can't do this until we simplify all of this. So let's multiply this out. A squared minus 3a plus 5a minus 15 equals 9. Now before we group, we need to get a 0 over here. So minus 9, and I get a squared plus 2a minus 24 equal 0. So don't ever attempt to factor until you get the 0 there. So my AC is negative 24. My B is 2, and this is a shortcut problem because there's a 1 here. So negative 1 times 24 won't work. Negative 2 times 12 won't work. Negative 3 times 8 won't work. Negative 4 times 6, that's my combination. A minus 4 times A plus 6 equals 0. Set each factor. A minus 4 is 0. A plus 6 is 0. Add 4. A is 4. Subtract 6. A is negative 6. Solution set, negative 6 and 4. So notice how we had to multiply out, move the 9 over, get it equal to 0 before we factor to find our answers. And the last one, number 25. We have y squared plus y plus 5 equals y plus 6 and y plus 3. So we simplify. This side I can't do anything to, but this side I can multiply this out. Y squared plus 3y plus 6y plus 18. So let's see, this is y squared plus y plus 5, and this is y squared plus 9y plus 18. Subtract y squared, and look, the y squares cancel out. So there's only going to be one answer this time, because look, my degree is a 1 now. So I'm going to subtract a y. I get 5 equals 8y plus 18. Subtract 18. 5 minus 18, negative 13 equals 8y. Divide by 8, negative 13 eighths is my answer. Only one answer this time because there's no square. Okay, but you don't realize that until after you follow the steps to clean it up. And there's no point in getting a 0 on one side. When it's just one equation, you just go ahead and solve that equation when it's to the first degree. So remember just a quick recap. When you factor, number 1, GCF. Number 2, you're going to count terms. Okay. If it's 4, you're going to group. If it's 3, you're going to AC it. If it's 2, you got 4 patterns to look for. Okay? Those patterns are a squared minus b squared is a plus b, a minus b. A squared plus b squared is prime. A cubed minus b cubed is a minus b. A squared plus ab plus b squared. And a cubed plus b cubed is a plus b. A squared minus ab plus b squared. And when you get ready to solve equations, number 1, you simplify both sides. Number 2, you set it equal to 0. Number 3, if the degree is 2 or higher, you factor. Number 4, set the factors equal to 0. And then number 5, solve each factor. Okay? If you only have one factor, you don't have to set it equal to 0, just solve it.